Hello, welcome back to another Rhize demo video. In this video, I'm going to show you how to create data on the Rhize database. Specifically, I'm going to show you some GraphQL mutations to create new manufacturing objects in your manufacturing knowledge graph. So here's what we're going to do. First, we're going to add a single item, then add a batch of items, and finally, we'll use a deep mutation to create a set of associated items. Before we get to our examples, let me give you a quick primer on the syntax of the mutation. Every mutation starts with the word mutation. Then it has a name that can be anything you choose. Next, specify the operation. This is the call you make to the Rhize API. In parentheses, add an argument that gives the input for this operation. Finally, specify what you want the API to return in response. It could be the object you created and some of its properties, or some aggregated statistics. All of this will make more sense with examples, so let's get to it. For our first demo, we're going to create a single piece of equipment. Here's the operation. You can compare it to our syntax cheat sheet. First, we have mutation, then a name. This name could be anything. It's to help you find and understand what the call does. Next, add the operation. This one's add equipment. For the input, add the equipment properties to create. In this case, I'm only adding the bare minimum, an ID and a label. The requested response is for the object we just created and a count of the number of new records created. I expect this count to be 1, so let's run it. As expected, we have one new equipment model, Kitchen Mixer A. Next, let's build on this to create a batch. To add a batch of items, all you need to do is turn the input from a single object into an array of objects. So we already have Kitchen Mixer A. Let's go ahead and make Kitchen Mixer B. And why not? Let's do Kitchen Mixer Q. Another thing to note, here we have the input as an inline argument. Typically, for better separation of concerns, this input is in a JSON variable. This becomes more important with larger, more dynamic input. So let's extract the variables, and now we can see the variables in a new section down below, and let's run it. Now we've got two more models, Mixer B and Mixer Q. This was a minimal example, but batch operations can be large. Rhize's API and database can handle a high throughput. With that said, let's do one more batch with larger, more complex data. So here we have our next example. This creates a number of job responses along with their associated material, job order, and work directive. Before getting into the details, just note that this is a fairly large JSON, getting close to around 5,000 lines. Let's go ahead and run it. So it worked, but now take a look at the response returned by the API. It's huge and way too verbose, reporting everything that we just created, all job response IDs and their nested properties. Typically, unless you're testing, limit responses to what is necessary, either useful information for the end user or maybe the data that is required for some secondary step. What's more, in an automated setup such as part of a BPMN workflow, all this extra response information is only going to bloat the network bandwidth for no practical gain. But unlike REST, GraphQL provides a way to control the response to return only the precise data you need. So now I'm going to run the same mutation with another batch of the same size and the same data structure. The only difference is the prefix of each entity. This time I'll request only the number of new records created. As you can see, the same number of new records, but for a smaller response payload. One interesting thing that happened here is that I have run a deep mutation, creating not only a job response, but some associated objects. However, since this data is fairly complex, let me explain with a more minimal example. In short, a deep mutation creates not only the top-level object, such as a job response, but also the associated entities that did not exist before. This mutation creates another job response, but the response includes a number of personal actual. These are the operators involved with the job. However, these personnel do not exist in our database yet. Instead, they are going to be created on the fly. To prove they don't exist, let's query for the personnel. If you notice, each ID starts with Acme Emp. Let's make a query for person objects with that prefix. As you can see, none of these personnel exist. Let's change that by running the mutation. So this created one job response and 10 other records. These are the new personnel. Let's jump back to our query and explore them. Now we have the operators associated with that job. They have their employee ID, their personnel version and name, Albert Einstein, Marie Curie, Charles Darwin. A very illustrious set of operators are working at this plant. Finally, let's explore the deep mutation a bit more with the example of the large batch. As you might have noticed, these job response inputs all have the prefix YT for YouTube, as do all the IDs of the nested data properties. One such property is the material actual, with information about the material's lot ID, quantity, how it was used, and so on. In a real plant, we might not be sure what the values of this data will be until the job actually runs. So this makes a great use case for the deep mutation, which simultaneously creates multiple objects and the links between them. This also brings up an interesting point about working with graph data. Since the Rhize DB is a graph database, this data is not hierarchical. So while we created job responses, we can query material through its own top-level operation, query material actual. And that's what we're going to do. So now I'm going to run the query, filtering for only material actual with the YouTube prefix. So now material is the focus of the response, with the associated job being only a property. But if you want to analyze or create reports on material, this view of the data is the most direct view for your need. Similarly, you could just as easily query by work directive or job order. This is a beautiful thing about graph data. You can explore the data from the perspective that makes sense for your use case. That's a big enough topic for a whole separate video. Thanks for watching.